Multiplication problem for lesson 3. All I want you to think about is figure out if we have a denominator. 1/9 of the students in Mr. Beck's class list red as their favorite color. Twice as many students call blue their favorite, and 3 times as many students prefer pink. The rest name green as their favorite color. What fractions of the students say green or pink is their favorite color? And we'll do the extension in a minute. Okay? Hannah, you missed that whole question. Do you need to borrow a pencil?
I got it.
Okay, great. So do I have a denominator? Because it says what fraction. So we have to figure out our denominator before we can ever start, because that's the number of equal pieces we need. You know what it is? Hayden, do you know what the denominator is?
The denominator?
Yeah, it said it in here.
1/9?
You got it. So it's not 1/9, but what's the denominator?
A 9?
A 9, okay? Or ninths. So I'm going to divide my tape diagram into how many equal pieces?
9.
9. Now 9's an odd number, and I know that 4 plus 4 plus 1 is 9. So that's why I started in the middle. And then I can put 4 on each side. Makes my life easier. Do I have a total? No, I don't. I don't know how many students are in his class. I don't even know. I mean, I guess the whole class would be one whole, correct? Or what? 9/9. But I don't know how many students I have. Or he has. Okay, now let's read through it carefully and see if we can figure out what to put on there. So it says, 1/9 of the students in Mr. Beck's class list red as their favorite color. So 1/9 choose what? Red. I'm writing it like this. If I do all those brackets, it's going to get too busy at the bottom. Okay? All right, the next one says, so this is what we know. 1/9 are red. Twice as many students call blue their favorite. 2/9. So I'm going to put 2 blues, and this time I'm going to make a bracket, and I'm going to write 2/9. Better move that one down. There we go. Okay, let me read the next one. And 3 times as many students prefer pink. Now the confusion here is 3 times as many as what? 3 times as many as blue, or 3 times as many as red? You're right. You have to go back to the very first one. So 3 times as many as red. So how many prefer pink? 3. So how many 9s prefer pink? 3 9s. 3 9s. Okay, so are you with me? Then it says the rest name green as their favorite color. Okay, and so here's the question. What fraction of the students say green or pink is their favorite color?
Green and 6/9.
6/9. Okay, so here's what I'm going to do. I'm going to do 3/9 plus 3/9, because one of those is green, one of them's pink, equals 6/9. Now I'm pretty sure that we've already simplified 6/9, or reduced it, or renamed it. Remember, they're all the same thing, aren't they?
Mm-hmm.
Okay, so what do you think the greatest common factor is for 6 and 9? You tell me what to write. Okay, she thinks it's a 3. We'll see. 1 times 6 and 2 times 3. 1 times 9 and
3 times 3.
So is the greatest common factor a 3?
Yes.
Okay, so I divide by 3.
2/3.
You're right. Equals 2/3. And what do you think I'm going to circle here?
2/3.
Yeah. The final answer, right? Okay, now do you think you can handle the extension?
Yeah.
We're going to give it a try, okay? So this is one whole classroom, isn't it?
Yes.
One whole classroom divided into 9 equal sections. Okay, here's what the extension says. If you know the answer, don't shout it out. Let the kids process, okay? All right, now are you with me? Did you write everything I wrote? Awesome. Don't let me forget to sign. Okay, if 6 students call blue their favorite color, so let's just say 6 students call blue their favorite, okay? How many students are in Mr. Beck's class? Well, to figure this out, I got to figure out one box. So this box right here is 6 or those 2 is 6 students. So my take, or was that Fernando? Both of you said, well, one box is 3 then.
Or it could be 1's 4 and 1's 2.
No, because when you make a tape diagram, they all have to be the same number when you multiply. Okay? So if that's the case, can I figure out the total number of students?
3. You multiply by 9.
Multiply 3 times 9. So the answer for the total number of students in the class is what?
27.
So the total class, or one class, right, equals 27 students. You did great. Okay, so that's another answer, isn't it? We're not writing sentences today. I want to get going here, okay? Oh, there's one more thing I forgot to add. What do you think I would get if I added all these fractions up right here?
9 9.
Very, very good. So one whole, right? Okay. Let's keep going. Now I'm going to try and not go too fast like I did in the last class. So here's what I want you to know. Those 2 boxes at the bottom, we're only going to use on the first problem. Then we're going to skip that part because it's just too much drawing, okay? But I want to show you that way the first time, just so you have a clear picture in your mind, okay? I'm going to use my technology expertise to show you. Are you ready for this? Okay, the first thing, now these are called fractional area models or fractional models, okay? First thing I want to establish is that each model is one whole. And we did this in lesson 1, sort of. So everyone write down what I just wrote. Don't stare into space, please. On the first model, now by the way, is there something wrong with this problem? Yeah, there is.
Oh, the denominator.
The denominators don't match. So our goal is to make them match, okay? There's a couple ways to say it. When I was a kid, they said it's called finding common denominators. Do you know what it's called today?
Division.
No. Like units.
So we have to make units.
No, that means the same. That sort of like means the same units, okay? If they're alike. Does that make sense? So you're going to see it, or you're going to hear it both ways. You're going to see it both ways, okay? All right, so the first step in finding common denominators, or like units, is to, are you ready for this? Here's the easiest way. Just multiply the denominators together. What are the denominators? So 2 times 4 is 8. So my new denominator is going to be 8, but we'll get to that in a minute, okay? So here's how you show it on an area model. The first area model, we're going to put the first fraction on. So you're going to cut it into 2 equal pieces and shade 1/2. So do that now. And actually, you don't have to write 1/2 on here yet. Okay, the second area model, this is very important. This is a mistake I made in the first block. You have to show 1/4, but your lines have to go horizontal or this won't work. Trust me. So shade 1/4. And I could go ahead and write 1/2 and 1/4 here just to show that I know what I'm representing. Okay, so the next thing I'm going to do, I'm going to show you what it looks like to add them together. Okay, are you ready? You sure?
Yes.
Well, we're going to have to copy a few things down below. So in order to do that, I have to make mine a little smaller. So I'm going to take this first one. Yes, but before I do that, I think I better erase, don't you? Because I don't want to copy that stuff. So I'm going to take the first one and bring it down to the next boxes. And you're going to have to draw it on there. Sorry. I know. It's a hard knock life for us. Hey, thank you. Okay, so go ahead. So go ahead and draw that again on the second one. And the only thing that we do differently, and I'm not even sure why we do this, is we combine. So watch what I'm going to do now. I hope it works. We're going to erase a little bit so I can make sure it combines. Okay, are you ready? I'm going to take these lines. These lines. Well, I'm not happy because I want to take these lines. Okay, I've got to draw.
I know what you can do.
I'm going to take these lines and put them over here to make 8. And I'm going to take that vertical line and put it here to make 8. So do I have 8 in both shapes now?
I got it.
Okay. I'm going to make this a little bigger so you can see it. And I need you to be drawing what I'm drawing. So now here's what I have. I started with what here? 1/2. And I started with 1/4. Okay? Now, what do I have? 4/8. And what do I have here? 2/8. So technically now I can add the fractions because the denominators are what? Both 8. So step over here, or go over to the side, start with 4/8. I'm not sure you wrote all this, Blair. 4/8 plus 2/8 equals what?
6/8.
6/8. Now that's not simplified because I know they're both divisible by 2. They're both even numbers. So I'm going to rewrite it so I can simplify it. So divided by 2, you guys write this, divided by 2. And what's my total? 3/4. We did. We already did 6/8. So that's how it looks. Now, we're going to make it shorter. because there's no reason to do the same thing twice, is there? No. So on problem 2, we're going to do everything on the first 2. You can cross off the last 2 area models if you'd like, or you could just ignore them, okay? You don't need these. Don't worry about it. Okay, now I'm noticing that since I'm not sitting over here, somebody's staring at the wall. Okay, so the first step, it's not Tucker. Okay. I'm going to show one hole, write everything I'm writing. On the first shape, I'm going to cut it into what? 3 equal parts, and I'm going to do it up and down or vertical, okay? The second shape, I'm going to cut it into 2 equal pieces, but I have to cut it across or horizontal. Now, this is where kids start messing up because they accidentally draw the second one the wrong way. They accidentally do this. And that's not going to work for this strategy. Ooh, that's bad, Mrs. Okay, so now, and here's what we do. We call it combine our lines. But before we combine the lines, I want to talk about the new denominator. Because what's the easiest way to find a new denominator? Multiply your 2 denominators. So what's 3 times 2? That will be our new denominator. Go ahead and write it. I know. Okay, so now, I'm going to go ahead and shade. So we know how many are shaded. And then maybe on the last one, I'll show you how to do it without the area models just for fun. Would you like to see that?
Yeah.
Okay, so here's how I do it. Look at my pen. I just kind of eyeball it. So this line kind of moves over here. Or it's copied over there. And these 2 lines are copied onto the next shape. So how many are shaded here? 2. And how many are shaded here?
3.
Now I can make a problem. 2/6 plus what?
3/6.
Equals
5/6.
5/6. You have to make sure and add. Okay, now whenever they're just one number apart, most of the time you don't have to simplify. What is it also called? Simplify is also called
1.
reduce
Oh.
or
Rename.
rename. Okay, let's look at the next problem. How's this one different? Because it is different.
That's different numbers.
True, but there's another something.
The numerator is different.
The numerator is not a 1. Now, in 4th grade and 3rd grade, you learned that when the numerator is a 1, it's called a unit fraction for 1 unit, okay, or 1 shaded part. So now we've got a unit fraction mixed with another fraction. So first thing you do, label your area models or your fractional models, okay? Write what you're adding at the bottom, and then start dividing. Pick your head up. So the first one I divide into how many equal pieces? 3. And how many will I shade this time?
2.
Okay, you still have 30 minutes of class, so you're going to have to just pick your heads up and think for me here.
2 minutes?
30 minutes.
Oh.
Okay. No, it's not. It's actually,
Because 6.
31. Right? 10:01?
Yeah.
Okay. So on this one, what's the number 1 mistake children make?
They go that other.
They try and draw them up and down or vertical, okay? So how many will I shade on this one?
1.
1. Now, in block 1, it worked. It's going to work. So all I have to do, are you watching? Is combine my lines.
Wow.
Now, when I combine my lines, it gives me a new denominator.
Well, it finally worked.
Yeah, it did. So, what's the easiest way to find your new denominator? Multiply. 3 times. So, how many equal parts will I have once I combine my lines?
12.
12. Okay, so here I go.
3/12.
Okay, just a minute. So this first one is 2, 4, 6, 8 twelfths. Hopefully you were thinking about the second one, Blair. The second one, and this is how Dwayne shows it. 1, 2, 3.
Meatballs.
How many are shaded?
I was thinking
3.
I was thinking about the second one.
I knew you were. Okay. So now that I have that established, can I add?
Yes.
Okay, so what am I going to add together? 8 twelfths plus 3 twelfths equals 11 twelfths. Now, I know last time I said when your numbers are like 1 apart, you probably don't have to simplify. There's another reason why you don't have to simplify 11 twelfths.
They're not both.
And what'd you say, Hayden? Okay. There's another reason why you don't have to simplify 11 twelfths. Does anybody know why? Julian, what do you think?
Put like the T.
When you factor them,
They're not gonna have the same numbers.
they're not. Tell me what you write here. 2 times, 3 times. Look at 11. The only factors are 1 and 11. What's this kind of number called? I'm going to start writing it. What? Prime. You learned that last year, didn't you? Okay? So, 5 is a prime number, 7 is a prime number, 11 is a prime number, 13 is, 17 is, 19 is, okay? They only have 1 in themselves as factors. So whenever your numerator is prime, you cannot simplify unless, like this would be a 22 on the bottom and it would be half. Okay? Unless you can divide your numerator into the denominator. Sit still, Tucker. I don't want you to lose all your focus and concentration. And I want to see your pretty hair. Okay. Let's look at the next problem. Thank you for being so great for my recording today, kids.
You're welcome in town.
Oh, yeah, well, thank you for that. Okay, so 2/5 plus 3/5. First thing I want to do is get those fractions, not 3/5, 2/3. And let's label the one whole. This one's a little different, so I really want you to stick with me. Since we don't have a 1 for a numerator, when I add them together, it's going to be a lot bigger. Okay? All right, so the first step. How many equal parts on the first shake, Fernando?
2? Oh, 5.
2 are shaded. We cut it into 5 pieces. And shade 2. Second fractional model.
You divided like that with the cross. Not
Cut
the
it into how many?
4, 3.
3. And Sadie said we're going across, so that's horizontal.
Yeah.
Okay, and how many will we shade this time?
My famous did my
2.
did what the other kids did.
Hey, that's what I did in the first block, Maite. And I went, oh, wait a minute, I'm going to have to record that lesson again. That's too big of a mistake. Okay, so should we see if the whole move it over thing works again? Is it going to?
Yeah.
So here's what it will look like, minus the shading, right? How many equal pieces do you think that is?
6.
How many? No, I want to know how many, just how many equal pieces? 15, good. How'd you get 15 so fast?
Because you have 3 times 5.
3 times 5, very good. This is a little bit like an array. So, watch how I write this. I know you're doing your lines, but stop for a minute and watch how I do this. Since I already know my new denominator, most of you are not watching. Still waiting, Daniel. Okay, since I already know my new denominator, I go ahead and write it. That way I won't forget. Now I count my shaded pieces. So 1, 2, 3, 4, 5, 6. Trust me, I won't circle all of those, okay? How many are shaded on the next one?
10.
Let's see. Hayden, how many are shaded here? Is it 10? Okay. So now can I add my fractions? Okay. So what will I add? 6/15 plus 10/15. Now this is where I need everyone to stick with me.
Oh, because the top one was bigger than the bottom one.
Right. So what's this kind of fraction called?
One.
No, I don't want to know the answer. I want to know what kind of fraction this is called. Improper. You almost said it, right? Improper. Okay, seriously? All right, so now I'm going to take 6/15 and I'm going to use the strategy we learned yesterday on the back, or maybe it was the day before, on the back of the problem set. Okay? So 6/15 is equal to 1 whole. What would 1 whole be? 15/15 plus, how many are left over after 1/15? And this is how they write it on Zern. So they'll go 15, no. They'll do 1 whole plus 1/15 equals 1 and 1/15. So circle that for your answer. Hayden, pick your head up. Okay, all that has to be written down. So if you didn't write it, you need to get it written out, except for I'm ready to turn the page. Okay, so do we have 2 more or 1 more problem? 1 more, okay. So on this one I told you I'd show you how to do it without the area models. Now we're not going to get to this until like, I don't know, 2 weeks from now. But it's really fun, okay? So 2/7 plus 2/3. Here's how I do it without the area models. So 2/7 and 2/3. And then I'm going to do equals. And I'm going to do that long line. Remember the long line? Yep. Okay. So I'm going to do 2/7 and 2/3. Then I'm going to figure out my new denominator. Blair, tell me what my new denominator is on this one. If you were listening the whole day, you would know that we have a strategy. The easiest thing to do is do what with the 7 and 3? No. Julian, tell me. Multiply the 7 times the 3. So what's my new denominator here? 21, because 7 times 3 is 21. So look how I have this set up. We're not quite ready for this yet, but this is how you do it. And I thought you might be curious to know.
Is that for 6th grade?
No, it's 5th grade in about 2 weeks. Okay, so what do you think I'm going to do now? I'm just going to make equivalent fractions, like we've been doing on the sprint. So Danielle, I want you to help me with this. 3 times what equals 21? What?
7.
Okay. So 2 times 7 equals 14. Okay, Daniela, 7 times what equals 21? Was that Daniela's voice?
Yeah.
So 2 times 3 equals,
6.
so now I can add.
Wow.
What am I going to add?
6, 21. Plus 14, 21.
Good. Tucker, I know you can't see very well, I'm sorry. So my answer,
20, 21.
6 plus 14 equals 20.
21.
21s. Okay.
Well, you can look it down the side.
Yeah, I know. Now make sure you wrote all that. We're going to start the problem set so you can put this in the sorter. But I want you